All right, so our essential question, I gave you the essential question for this chapter. And mostly the essential question is actually the same throughout the chapter because we're going to be talking about a bunch of different things that living things are made of. We're going to start with the smallest substance that we can, and then we're going to go up to big, huge compounds. So our key concept today, we are talking about water. Water's unique properties allow life to exist on Earth. Last week, we started with atoms, and then we moved up a little bit to compounds. Now we're going to talk about water, which is the most common and the most important compound for living things to be living things, to survive in their environments. So many compounds dissolve in water. Most of you that have cooked anything start with a pot of water and then you start adding stuff into it. So solution is formed when one substance dissolves into another. Daniel, you're unmuted. I don't know if you know that. You keep muting and unmuting. So if you've ever made Kool-Aid, some people have, some people haven't. I like to use Kool-Aid as an example for these words. So these are some good vocabulary words. So a solution is formed when one substance dissolved into another. Has anyone ever made Kool-Aid? Do you know what it's made of? No? Cynthia's never made Kool-Aid? Anyone else? Daniel's never made Kool-Aid. It's too sugary anyways, so nothing but sugar. That's right, Anthony. And the little packet, the little Kool-Aid packet that you pour in there. So Kool-Aid, you take a bunch of water, you take a little Kool-Aid packet, a little flavoring packet, and then you dump a bunch of sugar in there. So each of those pieces, the water, the Kool-Aid, the sugar, and then everything mixed together is something else. So the whole pitcher of Kool-Aid would be the solution. Solvents will take in or absorb other substances, and water is known as the universal solvent. So the fancy science name for water in a Kool-Aid solution is the solvent. And then solutes dissolve into the solvent. So the little Kool-Aid powder and the sugar, the solid things, will dissolve into the water. Those are called solutes. So when we make actual solutions in like a chemistry class next year, hopefully, if you guys take it, you will be making solutions and then pouring things in, trying to dissolve them, trying to do different things, and there's different pieces to that solution. So the solvent is 99% of the time it is water, and then the solutes or whatever powdery or solid substances go into the water. All right, the separation of water. Water always separates into equal amounts of hydrogen ions and hydroxide ions. So we know the formula for water is H2O. So we have 2 molecules of hydrogen and 1 molecule of oxygen. Well, we can actually separate that. When we separate it, 1 hydrogen goes on this side, and those are called hydroxide ions, and it takes a little plus with it, a little positive energy with it. And on the other side, the O and that second H go on the other side. It takes a little negative energy with it because the oxygen is more negative, and those are called hydroxide ions. And we study the pH scale. It is the mathematical expression of hydrogen ion concentration in a solution. So we can actually measure that hydrogen, and those hydrogen ions will actually make something more and more acidic. So the pH scale goes from 0 to 14. We have acids and bases. Acids on one side, bases on the other. Acids pH value is less than 7, so 1 through 6. and it contains more hydrogen ions, like I said. On the other side, you have the bases, can also be called alkaline solutions. pH value is more than 7, somewhere between 8 and 14. And it contains more hydroxide ions. You have less hydrogen. And then you have the middle, 7. A neutral solution has a pH of 7, and water is typically neutral. Humans like to mess with things, so yes, we've made alkaline water, but in a natural setting, water is neutral. So measuring pH. Scientists have special paper called litmus paper. Red litmus paper will turn blue with a base. Blue litmus paper will turn red with an acid. So they're little tiny papers. Actually, while you write this down, just stay there. Just kidding, stay there. Let's see if I can find it. Okay, this will be fun. So we have an acid. Look, I have lemon juice. So I'm going to take the blue litmus paper. Just little papers, little tiny strips. And let's see, if I dip it, you can see that the blue litmus paper turned red when I dipped it into an acid. That is chemistry. And then the other one, there's red litmus paper. Let me see if I remember. I don't remember. So this is how we test it. Because I don't remember. Let's see. I have soapy water. I don't remember if soapy water is an acid or a base. So what we do is we stick both of them in, the red and the blue, and we see which one changes. So I'm going to take both of them. I got a red and a blue. I'm going to stick it in the soapy water. And neither of them really changed. So if neither of them change, it's not an acid, it's not a base. What's our third option? We have acids, we have bases, and we have anybody know? We have neutral solutions. So if neither of them turns, all right, I'm trying to make the red litmus paper turn blue. So let's see, this is solution E. I use unknown solutions in class, they have to test. So let's see, oh yeah, look, the red litmus paper turned blue. So unknown solution E was a base because the red turned blue. So that was fun. All right, moving on. Polar versus nonpolar. This is actually our last slide. So the bonds between hydrogen and oxygen are not even. So water, H2O, you have two H's and you have one oxygen. The bonds are not even. Oxygen has a larger share of electrons, which makes it negative. I was telling you earlier that electrons are negative and oxygen is a negative atom. So when you put two hydrogens, which are just a tiny little bit positive, with one oxygen, which is a lot negative, the overall charge on the whole molecule kind of cancels each other out, but they also kind of push away from each other. They don't like each other. Positive and negative, the opposites don't attract. They actually repel each other. So the oxygen is trying to get, you can see in the picture, it kind of has its own share and it has the little negative. These are the electrons. So the oxygen end is negative, and the two hydrogens are a little bit positive. So the hydrogen end is positive. Hi, Giovanni. Welcome. So we call this a polar molecule. So just like the Earth has a North Pole and a South Pole, a water molecule has both a negative pole and a positive pole. So we call it a polar molecule. Not all molecules are like this. If the charges are all evenly distributed all the way around, that is called a nonpolar molecule. But water is polar. It has those two different charges, those two different poles. So, all right, that is it for the notes. So the video will be posted this afternoon. If you can get some of the blanks, if we went too fast. Make sure you write your summary. Some of you are turning in your notes without your summary, which means you don't get full credit. You get most credit, but you don't get full credit. There are directions on Canvas if you forgot how. I linked them. And then make sure you take a clear picture of them and turn them into Canvas. It's probably easiest to turn it in on your phone and take clear pictures on your phone if you have one. But do the best you can if you're taking it on your computer. That's okay. All right. I will. Let's see. Biology. We're going to share this one instead. So here's your directions for how to write your summary if you forgot.